Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of increase and decrease.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x squared over 4x plus 4, and we have to find the critical points, discontinuities, and the intervals where the function is increasing and decreasing. Well, first thing I notice, this is a rational function. So a rational function, we know we can't divide by 0 and be discontinuous there. So I take my denominator, 4x plus 4, and I set it equal to 0. Solving for x, 4x equals a negative 4, and x equals a negative 1. And so right off the bat, we have a discontinuity at x equals negative 1. So discontinuity at x equals a negative 1. Got that right off the bat. Well, now let's go find our critical points. So what we're going to do is take our function and find the derivative. Let's take some of the quotient rule here. So f prime of x here. All right, derivative numerator is a 2x multiplied by the denominator 4x plus 4 minus derivative denominator 4 times the numerator x squared all over denominator 4x plus 4 all squared. From there, we're going to simplify some things. So we have f prime of x here, numerator multiplied it out. 2x times 4x is an 8x squared. 2x times 4 is an 8x minus, this is a 4x squared. All over that 4x plus 4 all squared. From there, let's go simplify this a little more. F prime of x here. The numerator gets simplified. 8x squared minus 4x squared is a 4x squared plus 8x over the denominator 4x plus 4 all squared. Okay. Now, one thing we notice here, keeping the denominator, something happens at x equals negative 1. We're still dividing by 0, but we're aware of that discontinuity and that issue there. We want to find our critical points, so we're going to take our numerator, our 4x squared plus 8x, and we're going to see what this function is equal to 0. Okay. The denominator, if we're dividing by 0, we already found that. That's an issue. Again, like I said, can't use this. So we care about the numerator here. Pull x out. We have x times 4x plus 8 equals 0. Solve x equals 0. 4x plus 8 equals 0. And x equals a positive, or a negative 2. Negative 2. So now we have to make a little chart with our values here. We're going to make a little chart here. Okay. We go from decreasing to increasing. We have our critical point negative 2, discontinuity negative 1. Here, another critical point 0. Oops, I don't need this extra line. I added too many lines. It's alright. Alright. So from here, what we want to do is find where we're increasing and decreasing. That's what this first derivative test will do for us here. So what we want to do is first find an f prime. Let me separate this out here. F prime, I'm going to pick a value that's less than negative 2, and I picked a negative 3. When I plugged into my derivative, which right here, plugged into my derivative, I got a 0.1875. Don't really care what the number is, but it's positive. That means our function is increasing on that interval. Same thing, plug into our derivative, f prime of negative 1 was, negative 1, negative 1.5. See, we can't actually pick the critical value or the discontinuity here. We want to pick something in between. So an f prime of negative 1.5 is a negative 0.75, and again, we just care about the negative. Negative right there, we're decreasing. Pick a value between negative 1 and 0, and that I picked was a negative 0.5. Okay, so f prime, f prime of a negative 0.5, and it came out to be a negative 0.75. It's negative, it's decreasing. Okay. Lastly, pick a value bigger than 0. F prime, I picked 1, make it easy, and it came out to be a 0.1875. All I care about is that it's positive, therefore we're increasing. And this gives us our intervals here for our functions increasing and decreasing. We're increasing here from a negative infinity, right? Negative infinity to a negative 2. and from 0 to positive infinity. We're decreasing here from a -2 to -1. We have a discontinuity there, so we have to make a little break. And then we're decreasing from -1 to 0. And again, parentheses, we're not decreasing at -1. And so our final answer here, I didn't put the critical points down. Whoopsie. Forgot that. Critical points were a -2 and 0. X equals a -2 and 0. Almost forgot that. So our final answer here is we have discontinuity at x equals -1, critical points at x equals -2 and 0. We are increasing from -infinity to 2 and from 0 to positive infinity. And we're decreasing from -2 to -1 and -1 to 0. I hope this video was helpful for you. And if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you, for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.